Let's take a look at conditional probability. Conditional probability is basically asking the question, what is the probability of an event occurring given that a different event occurs first? All right, so this word or phrase, given that, when we write this symbolically, we have the probability of event A given that event B. This vertical bar right here is my phrase, given that. All right. The way that I find conditional probability is that I'm looking for the probability of A given that B. And so what I do is I find the probability of the intersection of A and B divided by the probability of B by itself. So if I do the intersection of A and B divided by the probability of B, that'll tell me the probability of A given that B occurs. So let's take a look at some examples of doing this. So I'm going to use the same two-way table for my first three examples. So here we go. So let's say I want to find the probability of randomly selecting someone who owns a cat, given that they own a car. So I'm doing the probability of cat, probability of car. So when I set this up, let's call this A, this is B. So I'm doing the probability of A intersection B divided by the probability of B by itself. So when I write this out, the probability of A and B is the probability that someone owns a cat and a car. So there's three people that own a cat and a car. So that would be, I have 3 over the total number of people to choose from, which is 35. Divided by, now I'm doing the probability of B by itself. What's the probability that someone owns a car? Which is 13 out of 35. So when I simplify this, you'll realize that my answer is 3 over 13. So the probability that someone owns a cat, given that they own a car, is 3 out of 13. And this does not simplify, so I am finished. The next example, once again, as I said, I'm using the same two-way table. This time we want to find the probability that someone owns a dog given that they own a truck. All right, so we'll call this event A, call this event B. So choosing a dog's event A, choosing a truck's event B. We're doing the probability of A union B over the probability of B. All right, so the probability of someone owns a truck and a dog is 15 out of 35. So we have 15 out of 35 over just the probability that someone owns a truck, which is 22 out of 35. So when I simplify that, I find out that it is 15 out of 22. Does that fraction simplify? No. I am finished. So the probability that someone owns a dog given that they own a truck is the probability of owning a truck and a dog divided by the probability of owning a truck, which gives me 15 over 22. Third example, using the same two-way table. So it should look very similar to what we're doing. This time we're doing the probability of owning a car given that person owns a dog. This is event A, this is event B. We're doing the probability of the intersection of A and B divided by the probability of just B by itself. So the probability that someone owns a car and a dog is 10 out of 35. 10 out of 35 divided by Just the probability that someone owns a dog, which is 25 out of 35. So when I simplify this, I get 10 over 25. As always, the fancy people or super smart people, however you want to think of it, that came up with mathematics decided that we have to simplify fractions if possible. In this case, 5 goes into both of those, so I end up with 2/5. And so those are my first 3 examples using a two-way table. The next 2 examples are a little more complicated, but let's take a look at these. I once killed 2 stones with 1 bird. When I look at this example, a teacher gave 2 tests. 32% of students passed both tests. 50% of her students passed the first test. What is the probability that students pass the second test given that they passed the first? So passing the second test would be my event A, passing the first would be my event B, and passing both would be A union B, which you might not be able to see that very well, but passing both means that they did both of this, passed the second and first test. So when I set this up, I'm still using the probability of event A given that event B. And in this case, we're told what the percentage is, or the probability of passing both, and we're told what the probability of B is. So when I set this up, it's important to make sure that I convert my percentages to decimals. So the probability of A and B is 0.32 divided by the probability of B, which is passing the first test, which is 0.50. So when I do 0.32 divided by 0.50, I get approximately 0.64. So this is the probability that students will pass the second test given that they passed the first. And what percentage is this? I would move my decimal 2 units to the right and have 64%. So 64% of the students would pass the second test given that they also passed the first. My next example is very, very similar. It's pretty much the same type of problem. It's a little bit longer, so I'm gonna have to do my instruction part of this on another whiteboard. But an archer has a 75% chance of hitting the bullseye with both shots. So with both shots, this is my A union B, my A and B. If the archer has a 90% chance of hitting the bullseye on the first shot, what is the probability of the archer hitting a bullseye on the second, given that they hit the bullseye on the first? So hit the bullseye on the first would be B, hit the bullseye on the second would be A, because we're doing A given that B. And so this 90% is my probability of hitting it on the first shot. So once again, I'm gonna set this up almost exactly like the last problem. All right, so we are looking at, the archer has a 75% chance, so we're looking for the probability of A given that B. Remember that A is hitting it on the second shot, B is hitting it on the first shot. So we're doing the probability of both A and B over the probability of B. All right, so when I do this, the probability of A and B, we're told is 75%, so we're gonna call that 0.75, divided by the probability of B, which is 0.9. All I did was convert those percentages to a decimal instead of a percent. So when I do 0.75 divided by 0.9, I end up with 0.83. And if I move the decimal 2 units to the right, I end up with 83%. So the probability of hitting a bullseye on the second shot, given that they hit a bullseye on the first shot, is 0.83, or approximately 83%.